Good morning, students. Hope you are doing well today. It's been a little while since we did some college algebra, so it's time to get back at it. We are talking quadratic equations, standard 6. We did one lesson last week. We're going to jump into lesson 8.2 today. Hopefully you've already had a chance to take a look at that a little bit. There are some things that I'll say about what the book goes through in the lesson as we go through today. Oh boy, I didn't do my hair, sorry. Let me first take you through the rubric a little bit, and not really through the rubric in a detailed way, but just in general. What are some of the biggest things that you need to know for this standard? And one of those big things is know how to take a quadratic equation and put it into any one of three forms. There's actually three forms. The first form is probably what you're most familiar with. It's called standard form. You worked with that a little bit last week. That's your y equals ax squared plus bx plus c. When you go from a quadratic term and a linear term and a constant in that form. Okay, standard form. The second one, which we're going to work with today, is called the vertex form. Okay, and that looks like this. You factor out an a from the first two terms, and then there's a little more to it than that, I should say, but it's in this form here. And so we're going to discuss that in detail today. And then the third form is called the factored form. Okay, that's when you have, you still have your a out front, and then you have x minus, and I don't even know if they give us specific values for this. We'll just call that R1 times x minus R2, right, where you have it factored. Okay, we're not going to get into that for a little bit, but each one of these forms have their benefits, and as we go through and learn them, you'll see those benefits and use those to help you. You are going to need to be able to recognize these forms, obviously say what kind they are, but also be able to take something in standard form and put it in factored form, or take it from standard and put it in vertex form, or take vertex and put it in standard, or vertex and put it in factored. Basically, just go from any one to any other one. Okay, so you got to be pretty flexible with this. It involves some algebra, but that's kind of the end game that we're going for. All right, so now that we have that quick overview, the other thing that I want to focus in on today is the key features of vertex form. And we are going, mainly just that. All right, so vertex form, again, is just f of x equals a times x minus h quantity squared plus k. And it's important to note that hk is your vertex of the parabola. That's the lowest point, right, down here, or the highest point if it's concave down, right? So this is going to give us our vertex. So you're going to be working on three different types of problems today. I'm going to quickly go through some examples to help you with that. You're going to be doing number 7 today. There are 4 parts to that, but I'm going to do one of them for you here. This is 7C, and so I believe it says, for each of the following quadratic functions, find the vertex hk and determine if it represents the maximum or minimum of the function. So for C, we have f of x equals -5 times x plus 4 quantity squared minus 7. So it gives you that function right there, and it says, hey, can you find the vertex of that? Well, the vertex, if we look back to our general form here, that h value, that first value here, looks like it's right here, this 4. But notice that in the formula it's a minus h, and so here it's a plus this. So in order for, well, let me just say it this way, the h is going to be -4, okay? Because you could change this plus to minus so that it matched that, but then it'd have to be a -4 there to continue for that to be a plus like we started with. So minus a negative 4, so that means negative 4 is your h, and then your k value is negative 7. So negative 4, negative 7 is your vertex, and we know this is a maximum. How do I know it's a maximum? Because my a value is negative. Anytime that's a negative value, that means your parabola is opening downward, so that means your vertex is at the highest point, therefore a maximum. Okay, so that was 7C. You can get a new color here. Mine was kind of going bad there. Next, we're going to look at 9C. This problem says create a quadratic function in vertex form and then rewrite the function in standard form. So this is helping us rewrite these functions. So they give us a is at negative 2, and they give us the vertex, which is at negative 3, 1. Right? So here we go. Y equals, or f of x equals, it doesn't matter how you write that, our a, negative 2, times x minus, notice I start with a minus before I even look at my h, minus a negative 3, and then plus the 1. Now obviously minus a negative is going to turn that into a plus positive. So there's the first part of your equation, very easy. Now if you're going to put this in standard form, you're going to first, you're not going to distribute this negative 2 through first. You have to do the exponents first, order of operations. So x plus 3 times the quantity x plus 3. Right, I'm writing out what it means to square that binomial. So if I do this, I have to do the FOIL. First, outer is 3x, inner is another 3x, so that's 6x total. Those are like terms. And then 3 times 3 is 9. I can distribute this negative 2 through now, so negative 2x squared minus 12x minus 18 plus 1. We'd be able to combine those two together there to give you a negative 17, and I would rewrite that below here, except I ran out of room, so I'm not. There you go. There's your answer, 9C. And finally, number 17. You guys are actually going to do number 13, but I'm going to show you 17. It says determine the equation of the parabola whose vertex is at 2, 3, and that passes through the point 4, negative 1. So the vertex is at 2, 3, and it goes through the point 4, negative 1. Okay. All right, so here we go. Plug it into your form. Y equals a, we don't know what a is, times x minus the h is 2, the k is 3. So we have it just like that. Now, we'd have it done except we don't know what a is, right? That's what this is going to tell us. They tell us the point that it goes through. So we could do a whole bunch of guessing and checking to see what a would go through that point. But let's think about this. This point has to make this equation true. It's a point on that curve. This is an x, this is a y. So why not just take the y value, plug it in for y, the x value, plug it in for x. Okay, we did this with exponential functions last standard. We're just doing it, same thing with quadratics this time. Plug them in for x and y. Now we just have an equation where we just have to solve for a. So I'm going to subtract 3. So I'm left with negative 4 equals a times, now I'm going to evaluate this. 4 minus 2 is 2, squared is 4. I'm going to divide both sides by 4. Oh, look at that, negative 1 is a. That was easy. So then I'll rewrite y equals negative 1 x minus 2 squared plus 3. And that is our answer. All right. So just a lot of algebra today, trying to understand some basics of this. I do want to point out the lesson primarily focuses on thinking about parabolas as transformations. So remember back in geometry when we did transformations, reflections, rotations, and translations, just where you slide it, okay? So as you read the lesson, it's not gonna give you this right away. It's gonna kind of explain, okay, why did we do a plus k? Well, that's gonna be like a translation up and down. Why did we do the minus h? Well, that's gonna be a translation left and right. Why did we do the a? That's gonna be like a dilation. It's gonna like widen it out or narrow it up or flip it over. So all these things kind of have a reason for why they're there, and the book focuses on that more. So hopefully that, now that you know that, that maybe makes a little bit more sense of what you read, but hopefully it goes okay. So I look forward to hearing from you soon. Get your work done and keep plugging away. Hope you guys are doing well.